The Skylab crewmen were launched in an Apollo command module for missions of 28, 59, and 84 days. The launch of the unmanned workshop was designated Skylab 1. The subsequent 3 manned launches were designated Skylab 2, 3, and 4, respectively. The Apollo command module, with 3 astronauts aboard, was put into orbit with a Saturn 1B launch rocket. After orbital insertion, the spacecraft was flown to the orbiting workshop for rendezvous and docking. The partially deployed solar panel can be seen, and other damage to the workshop is shown by the gold shiny area where the micrometeorite shield was torn away. After initial inspection, the spacecraft approached for the final docking with the orbital workshop. This tour through the Skylab cluster was photographed by the first crew to visit Skylab. The camera, propelled by one of the crew, floated through the multiple docking adapter, through the airlock module, and into the orbital workshop. The workshop is 22 feet in diameter and roughly 58 feet long. The first floor area contained consumable supplies, workstations, and scientific equipment. The second floor contained the crew living quarters and the medical experiments area. The galley area had a large window for observation of the Earth and stars. The crewmen developed techniques for moving many large items of equipment with relative ease. Pete Conrad is moving an item of scientific equipment over to mount into an airlock. Locomotion was easy, as well as an enjoyable experience. The crew was able to run around the dome lockers easily. After a little practice, tumbling and acrobatics could be performed with ease in the weightless environment. The next series illustrates the operation of the major in-flight medical experiments. The first of these are the cardiovascular studies. A lower body negative pressure device was employed to provide a stress to the cardiovascular system and to permit continuous physiological observations to be made, as pressure on the body below the waist was reduced to 30, 40, and 50 millimeters of mercury below the ambient pressure. Blood pressure, vector cardiogram, heart rate, and leg volume measurements were obtained. The test was performed approximately every 4th day of the mission. The film first illustrated the entrance of the crewman into the device, the closure of the rubber waist seal, donning of biosensors, and the operational activity of the astronaut observer. Exercise capacity was studied using a bicycle ergometer and metabolic analyzer. The crewmen exercised for 5 minutes at each of 3 progressively higher work rates, and the physiological response to this stress was measured. These measurements included blood pressure, heart rate, vector cardiogram, oxygen consumption, carbon dioxide production, and respiratory volumes. The ergometer also was used by the crewmen for daily personal exercise. The function of the vestibular system was studied through the use of a rotating litter chair. One part of the study was the determination of susceptibility to motion sickness during rotation in the chair at speeds of 20 and 30 revolutions per minute while performing a series of head movements. The crew was trained before flight to recognize the slightest motion sickness symptom, and their susceptibility was graded by this subjective method. Sleep studies were conducted on one crewman during each of the 3 manned missions using an electroencephalogram cap and sleep analyzer. The preparation of the cap and servicing of the electrodes are shown. Analog signals were recorded on board the spacecraft and were converted by the sleep analyzer into telemeter digital signals, which indicated the 5 sleep stages. This is one of the sleep compartments and sleeping bags used by the crew. Special equipment was developed to collect, process, and preserve blood samples during flight. Once each week, samples were acquired using a conventional syringe and transferred into an evacuated sample processor. The processor was placed in a centrifuge for the separation of plasma and cells. While still under centrifugation, plasma was forced into a separate collection vial. This automatic separation was required because of the unique behavior of liquids in zero gravity. After separation, the blood samples were placed in a freezer for preservation and returned to Earth for post-flight analysis. This scene shows the details of the transfer from the conventional syringe into the sample processor and the placement of the sample processor in the centrifuge. A series of experiments was conducted to study mineral balance and biochemistry of body fluids. In the mineral balance study, the ingestion of food and beverage was carefully controlled to maintain a near constant intake of electrolytes, protein, and other dietary components. Beverages were packaged in bellows containers and freeze-dried foods in plastic bags. Both were reconstituted by adding measured quantities of water. Food trays were used for both food preparation and dining. The Skylab 2 commander is shown preparing a freeze-dried food and is now kneading the food before placing it into the tray. The tray had 7 recessed openings to hold food cans. 3 of the recessed openings provided controlled heaters for warming foods. The crewmen ate with conventional tableware and expressed satisfaction with the food system. At the suggestion of the first crew, spices to improve flavor were carried on the subsequent missions. 70 foods were provided from frozen, thermostabilized, and freeze-dried foods. A mass measuring device was used to weigh food residues and fecal specimens. The food can or specimen was secured to a table mounted on a spring suspension. The frequency of oscillation of the table and added mass was recorded, and from this measurement, equivalent Earth units of weights were calculated. Equipment was provided in the waste management compartment to collect, process, and preserve urine and fecal specimens. Urine was collected daily in a pooling bag. The crewman transferred a 100 milliliter sample into a smaller specimen bag, which was placed in the freezer for preservation and subsequent post-flight analysis. This scene shows the operation of the transfer of urine from the pooling bag into a sample bag. Lithium chloride tracer had been placed in the pooling bag before flight to permit post-flight volume determinations based on lithium dilution. Each day, a new urine pooling bag was placed in the urine collection system. This scene shows the operation as performed in flight. 3 drawers contained the equipment necessary to provide each crewman with a separate urine collection system. The overall operation of the waste management system was faultless throughout the flights. Daily body weighings were made on a mass measuring device, which operated on the same principle as previously described. The crewman was strapped into the device, and the spring released to allow the chair to oscillate. The equipment was carefully calibrated on all 3 missions, and the weighing devices proved to be remarkably accurate. On the first manned mission, the crew exercised daily for approximately 30 minutes on a bicycle ergometer. On the second mission, the exercise time was approximately doubled, and a simple rope tension device was launched with the crew to allow them to exercise the arms and back muscles. On the third mission, the exercise time was increased to approximately 90 minutes per day. And a unique treadmill-like device was used for the first time. Rubber bungee cords applied about 170 pounds of compression to the legs, enabling the crew to simulate walking or running on a smooth, low-friction Teflon plate, and thus exercise neglected calf muscles, untouched by bicycle exercises. An in-flight medical dispensary was available for crew health care. This included medical, surgical and dental, diagnostic and therapeutic capabilities. In addition, a microscope, slide stainer, and specimen incubator were provided for clinical microbiological work. All crewmen received approximately 80 hours of paramedical training in the use of this equipment. Extravehicular activity played a major role in the success of the Skylab program. In a time and motion study, spacesuit donning was evaluated. On each of the 3 missions, man proved that he was a vital link in the repair of components external to the spacecraft. The EVA photos show a film pack being delivered to a crewman at the EVA workstation. Such EVA activities were performed almost routinely throughout the program without major problems. This last in-flight sequence shows the orbiting workshop with the thermal screen and the 1 solar panel deployed. Landing was accomplished with the 3 parachute system as used in the Apollo program. Recovery differed from the Apollo mode, however, in that the Skylab command module was lifted directly from the sea to the recovery aircraft carrier, and the crew egressed onto a platform on the carrier deck. This scene shows the Skylab 2 crew egressing from the command module. The crew returned in relatively good condition. They did experience some postural instability, and one of the crewmen suffered motion sickness while waiting for pickup. The crew took approximately 18 to 20 days to return to normal pre-flight baseline values, as determined by exhaustive post-flight testing. Dr. Kerwin is the last crewman to leave the spacecraft. You will note that as the crewmen walk along the red carpet, they work to maintain lateral stability. The crew reported that some residual lateral instability persisted for several weeks. The Skylab 3 crew was retrieved about 35 minutes after splashdown. For this recovery, a platform was mounted level with the command module hatch, and chairs were provided for the crew to be seated. This was done to reduce the effects of Earth gravity on the crew as they waited to be moved into the mobile laboratories for the post-flight medical tests. Recovery procedures for the crew of the 3rd manned mission were identical with those of the 2nd manned mission. Dr. Gibson is shown here, leaving the spacecraft. As you can see, he is in excellent condition. Jerry Carr, the commander, was the next to leave the spacecraft. You will note the crewman wearing the cardiovascular counter-pressure garment. The inflated capstan device, which provided mechanical counter-pressure to the legs, can be clearly seen. These garments were used by all Skylab crewmen to counter effects of orthostatic hypotensive tendencies on return to Earth. The last crewman to exit is Bill Pogue. All of the Skylab 4 crewmen returned in excellent condition, and within 4 to 5 days, they were back to their pre-flight baseline norms. In conclusion, most of the biomedical problems predicted during the early years of manned spaceflight, relative to man and the space environment, did not materialize during the total 171 days of the Skylab manned missions. Those physiological alterations which were documented by the Skylab medical experiments were generally accommodative in nature and were not serious enough to impair the ability of the crew members to work effectively in the weightless environment. In general, the Skylab medical findings confirmed and extended those of the shorter Mercury, Gemini, and Apollo flights. Crewmen were carefully studied during the pre-flight, in-flight, and post-flight phases of each Skylab mission. The principal findings resulting from the intensive Skylab biomedical studies were space motion sickness during early flight, moderate bone mineral losses comparable to those observed in man during prolonged bed rest, moderate cardiovascular deconditioning, and reduced effective circulating blood volume as reflected by the loss of red cell mass and plasma volume. In the early post-flight phase, orthostatic intolerance was observed similar in degree to the late mission responses to lower body negative pressure. Exercise intolerance was not observed during flight, but was characteristic of the early post-flight period. Despite the foregoing observations, the Skylab medical experience has emphasized the ability of man to live and work effectively in space for extended periods of time. Appropriate nutrition, programmed adequate sleep, work, exercise, and recreation periods, and suitable work areas must be provided to maintain crew health and well-being.